Okay, so we are looking at now, we're going to look at data transformation. So data transformation means when we change a bit of the data to transform it. And what we mean by that is when previously we've had our linear regression. So we've had our response and our EV, and we've had a scatter plot, and we've popped in the line, the least squares regression line. So if we put in this line and we assumed it was linear, most of the time we assumed it was linear, did the regression analysis, and then we got down to the residual plot. So we got down to the residual plot where so this was the residual and these were still the EV values. So what we said is if it was random, it was linear. If we saw a pattern in it, so sometimes if you see this, like we're going to see a pattern or something in the residual plot, then we said it was nonlinear. So this is where we're heading now. So when we decide that the data is nonlinear, so we can see a pattern in that residual plot, we are now what we're going to do is transform the data. So it means we're going to change one of the variables by a little bit. So when we transform, maybe write a note, we only change one variable at one variable, okay? And the way we could change them is we could square them. So what that means is we could square the EV values or we could square the RV values. That could be one change. We could do a log transformation, which is we would log all the EV values, or we could log all the RV values. And our last type of transformation we could do is we could do the reciprocal. Now, the reciprocal means 1 over. So we could put all the EV values like that, 1 over EV, or we could do all the RV values. So you're only ever going to do one transformation. So that comes to our next question. So we've got to the residual plot and we know we've seen there's a pattern. So the residual plot has shown a pattern, and we are now going to, so therefore we're going to transform the data. So this circle is how we're going to distinguish which transformation we could do, because essentially we have 6 transformations we could do. We could do the squaring of either the EV or RV. We could do the logging of the EV or RV, or we could do the reciprocal. So there's 6 choices. So how you choose, so this over here, this circle is how we choose which transformation. So transformation. All right. Okay, I'll just abbreviate that. So if you look at your original, and this is looking at the original scatter plot. Okay, so if you look at your original scatter plot and it goes and it follows looks like that. So when you'll see it in a minute, if it looks like that, therefore it's good to do either a y squared. Now we don't really call it y now, so maybe you might want to write RV squared, or you could do a log 10 of the EV, or you could do a 1 over the EV. Okay, so there's appropriate. If your scatter plot looks like this one over here, you could do a squaring of the RV values or a squaring of the EV values, like that. And then if it looks like this part of the circle down here, you could do a log 10 of the RV, or a 1 over the RV, or a EV squared. Okay, so these are the options, and obviously over here, just make it a log 10 RV, 1 over RV, or a log 10 EV, or 1 over EV. All right, so now we're going to, so there's the options. So you're only going to change one variable, and you've got all these options, but we'll use this circle to decide which one. Now, if you look at the circle, we've got a couple of options for each scenario. So say up here, if my original scatter plot looks like this one here, well, I have two options. So I've got one option here, or the other option is this. So therefore, if I do that and I change the data, and then what we're going to do, we change the data, then we have a look at the residual plot. If the residual plot is now showing that it's linear, well, for both of them, we need to know which one's better. So then we will look, and it says it here, we will then look at the R squared. Whichever one has a higher R squared, that's the better transformation. So let's go and give some examples a go. So if we look at this first one, so I'm going to show you on the calculator. So I've prepared it a little bit earlier. So let's go and pop it in. So we've got a squared transformation here. So I've put in time, and I'll type in my list height, okay? So we've done that. It says you need to construct a scatter plot displaying height as the RV. So if I go to draw a scatter plot, so I'm going to put height here, and I'm going to put time there. Now, you could say if we went and did an equation, the least squares, we're assuming it's linear. So I'm going to go to pop on the regression line. And the reason I'm doing that is so I can get the residual plot. So then we'll go analyze residual plot. Now, can you see a pattern in that residual plot? 100%. That one is definitely a pattern. So that means I'm going to transform the data. So looking back here on the notes, here's the original scatter plot, what I first did. Okay, so write original scatter plot. Now, because it looks like, if you think about the circle up there where it described what transformation, would you agree that this bit looks like that part of the circle? Yes? So this circle up here. It looks like that, doesn't it? Yeah. So these two transformations are going to be the ones that I could pick. So the two possible transformations I could pick here, it was the RV squared or the EV squared. So I'm going to do the first option. I'm going to try and do I'll do this as my first option, is the EV squared. Okay, so how do you transform the data? So going back, you would have your lists in. So sorry, I'm just getting these up again. You'd have your lists. Now, you want to create a list of the explanatory variable all squared. So because it was time, I'm going to call it, I'll call it squared time, okay? And I give it a name. Now, underneath here in the grey, the little grey tile underneath the name, you press equals. And it should say whatever you called it, and then it's got an equal sign. So now I'm going to tell the calculator to square time. Now, so I open up brackets, and I wrote the word time because that's what I called my EV. And I close the brackets, and I'm going to say square it. And so I've done the square function. When I press enter, that's all those x values or explanatory variables squared. So now what we're going to do is we go back to creating a scatter plot. If we have a look here. So if I use square time instead of normal time and height, do we now have a linear relationship? Yeah. Now let's double check it. And we'll go analyze regression A plus BX. And now I want to see the residual. Now, what should my residual look like? Because it looked linear. So what should the residual look like?
Not linear.
What type of picture? Scrambled, good, random. Is that random? Yes. Right. So you could say, so this one is, yes, it makes it linear because the residual plot is now random. No pattern. Now, because we're going to check another one, we want to know what the R squared value would be. So this one's equation now is actually now, I would write height. So if I was writing out the transformed equation, so let's go back and do that. If I go back here, I'm going to get the equation of the transformed data. So we do the same, menu stat calculation, A plus BX. So here, instead of picking time, I'm going to pick squared time. And I didn't change the RV because you only change one. And I click OK. So if I was writing out the equation for this new transformed, an EV transformation, I would write 150, I'm going to write 6, sorry, I'm just going to do the nearest whole number there. And then I'd write minus, I'm putting the gradient there, so negative 4.90, I'll just do 1, times, now it's going to be time squared, because now I'm not using just time, I'm using time squared. So that would be the new transformed equation. So if you want to write underneath, there's the new transformed equation. And if we wanted to, we're going to have to check which one's better. So the way we check which one's better is to go to the R squared. And this one's R squared equaled, it's nearly, if you round it, it ends up being 1. So it's a perfect. So that actually was a squared relationship. So anyway, so we got that. So let's have a quick look at if we squared the RV. So if you were going to do a response, so you have your original list there. So I've got my original list. Now I'm going to square the height, which is the RV. So I go equals, open up the bracket, height is what I called my RV. I'm going to square it, press enter. That's all the height squared. Now, if I go and have a look at this scatter plot, let's see if it straightened it up. So I didn't change time. So time remains time, but I changed this one to squared height. It looks straighter, but not as good. But let's check the residual plot. So you can't get a residual plot unless you have that regression line. So I've done that. Analyze, residual, show residual plot. Now, is that still a pattern? Yeah, so R squared didn't make it linear. So I would say no to this being a proper transformation. So it's only going to be the X squared values. So we could write a little statement there that it's non-linear still, because residual plot shows pattern. So it is not trial and error. I had 2 to pick from, and I had to do that. The circle said to try an R squared or an EV squared. An RV squared, a response variable squared, or an explanatory variable, and we did that. So the explanatory variable is the best one. I'm going to stop.